reflecting graphs. Notice I have this nice picture here with this tree being reflected in the water. That's kind of why we call it reflecting graphs, because it's going to, in a sense, reflect across the x. Here's our normal graph of like x squared. F of x equals x squared. Upside down, upside down, upside down. And that's exactly what happens. This graph is now turned upside down, or it's reflected across the x-axis, and it's negative x squared, because all that happened was this. Whatever value, when you have it, even when you have x is negative and you square it, becomes positive. All the values are positive on the f of x equals x squared. But a negative in front means take all those y answers that were positive and make them negative. Well, if all the y answers are going up in the graph, all the negative answers are going down, hence the graph reflects across the x. And we call it reflecting across x. And you'll notice here, reflect across x. And that's what a negative does. It just flips it from being positive to a negative, reflects it across x. So reflecting graphs do the following. Now, and this is what we see right here. Reflection in the x-axis is when there's a negative in front of the entire thing. We will talk about a reflection across the y-axis at another time, but not so much with a quadratic function, because they are even, and whether the value is negative or positive, it turns out squareds of a negative times positive. So you won't see these in this one, but you will see that. I'm foreshadowing some future learning. Just know if there's a negative in front of the entire thing, or in front of the a value, your graph will go down and not up.